Multiple representations, checking equations. You should have this problem in front of you. Mr. Rogers is starting a record label company. He's planning a party for potential new artists. There's a flat fee of $275. That is important, so let me just point that out with my laser pointer because it's really cool and I want to use it. So a flat fee of $275. That means that it's one time, it doesn't change, to reserve a room at Mariana's restaurant for the evening, and a charge of $20 per person. This per person is going to change because the number of people could change. $20 per person for food and beverages. If Mr. Rogers has $1,250 to spend, write an equation to find the maximum number of potential new artists he can invite. So the first thing that we're going to do is write down our variables. So we know, I'm not going to say that $275, the flat fee, is a variable because that doesn't change. It stands on its own. But I am going to say that P, which is the number of people, will change. And remember that it costs $20 per person. The $20 doesn't change, but the number of people could change. So P is going to stand for people. And then I know that the more people he invites, that's going to change the total amount that he spends. So the total spent is going to be here. Now let's talk for a second about dependent and independent variables. The number of people determines the total spent. So this is going to be independent. The number of people is going to be our independent variable, and T, our total spent, will be our dependent variable. So if we were to graph that, this independent would go on the X and the dependent would go on the Y. But we're not asked to graph it, we're just asked to write an equation. So to write an equation, we know that our total, the total that he spent, will be equal to the flat fee of $275 plus $20 times P, number of people. Now, in this particular situation, we are asked to find how many people he could invite if he has $1,250 to spend. So what I'm going to do is I'm going to replace my total with the total that I'm looking for. $1,250 equals 275 plus 20p. So that is my equation that I could write to represent this situation. And I could solve that equation to figure out P, number of people. Now, the next part of this says that Sophia says that Mr. Rogers can invite a maximum of 48 people, but Christian says he can invite 49 people without going over his budget. So we need to determine who is correct. So let's go back and let's look at the equation again. We know that $1,250 we know can be equivalent to $275 plus $20 times P, number of people. To check this, all we have to do is substitute in 48 people for P and then 49 people for P. So let's go ahead and do that. 1,250 is equivalent to 275 plus 20 times 48. So I'm just going to solve this side of the equation. 20 times 48 is 960 plus 275. And all of that is $1,235, which is less than $1,250. The maximum he can spend is $1,250. And by inviting 48 people, he will spend $1,235. So yes, Sophia's right that he can have 48 people, but let's see if that's actually the maximum. So let's go ahead and take what Christian says. So we'll say 1,250 equals 275 plus 20 times, instead of 48 people, Christian says 49 people. So 20 times 49 is 980 plus 275. And all of that equals 1,255. Which is greater than 1,250. So the problem is that his maximum budget is $1,250, and Christian, by inviting 49 people, is over his budget by by $5. So who is correct? Sophia is actually correct. So from this video, I really wanted you to get that all you need to do to check an equation is plug in values for your variables. Pause, rewind, rewatch until you make sure that you understand, because tomorrow when you come to class, you will have a couple of equations where you will have to plug in values for your variables.